Artificial intelligence, or AI, has been a huge topic lately. So here at Microcenter, we decided let's just dive right in, and we want to show you how you can set up a local AI PC that can handle large language models. Now, this process requires no coding, and it can utilize RAG, or Retrieval Augmented Generation. And we'll talk about the hardware required for local AI, some of the applications that we're using, such as LLM Studio and anything LLM, and we'll also go over some prompting and other general tips. Now first, I'd like to introduce you to Al. Al is our AI workstation that we put together on this test bench with some of the best consumer components on the market. So Al has a 3090 Ti, which has 24 gigabytes of VRAM. That's a lot of VRAM when it comes to gaming or video editing, but when it comes to local AI use, it's just scratching the surface. Now we also have 192 gigabytes of DDR5 RAM, as well as a 14900KS CPU. So as far as consumer PC parts go, everything that Al has is top tier. But again, this is just scratching the surface. With higher-end AI workstations, you'll see a Threadripper or Intel Xeon CPU, and that's going to be paired with multiple GPUs. This is more demonstrative of what you can do with consumer-level parts before getting into a higher-end workstation. Now, one thing to note is that you can see I have a 4070 Ti Super and a 4080 Super on the table with me. These both have 16 gigabytes of VRAM, which again is a lot for gaming and video editing, but depending on the parameters and quantization of the models that you're using, it might not be enough. Before we get into the process of setting everything up on Al, let's talk about some of the jargon that you're going to hear when getting started. Artificial intelligence can be a lot of different things, and it's existed in many forms for years. What makes AI exciting these days are LLMs, and that's been developing a lot in recent years, and they're getting better trained. LLMs are large language models, which are a generative form of AI. This means that it generates text, in the same way that an image generating AI generates images, audio generating AI generates audio, video generating AI generates video. You get the idea. LLMs are trained only on text, and they only output text. They're predictive in nature, meaning they're not deterministic with the results that they give. They're only predicting the next word based on what it's trained on. Now, there's plenty of models available, such as Llama 3, which was just released a few weeks ago, and this has an 8B and 70B model. Now, the 8B and 70B are the parameters, which are pieces of data that work together to define the behavior of an AI model. The simplest way to think about it is the more parameters, the more data contained in the model to draw on to generate better outputs. So an 8B model has 8 billion parameters, and a 70B model has 70 billion parameters. So a 7B or 8B model is the sweet spot for many people to run on a variety of hardware configurations with ease, while also generating a pretty good output. A 70B model, or even a 400B model, requires a lot of computational power to work. So Al here is running with a 70B model of Llama 3, but I believe it's a Q1 or a Q2, and that's the quantization. So quantization is the precision of the model. The higher the quantization, the better the precision. The lower the quantization, the lower the precision. Now, this allows you to run larger models by reducing the number of bits of information in that model, but lowers the accuracy of the model, and it basically makes it less smart. A lower quantization reduces the size of the model so it can run better on your hardware. So the most that I can do with Al and this 3090 Ti is a 70B model with that Q1 or Q2. I can't run a full quantization of a 70B model with this hardware. Well, actually I can, but it's incredibly slow to the point of being unusable. So why run a larger model at a lower quantization instead of a smaller model at a higher quantization? Well, the easiest way to think about it is that even at a lower quantization, the larger models still have billions more parameters than these smaller models. Now, this all boils down to use case, and not all models are created equal. Some are better than others at different quantization. You can use an 8B model with a lower quantization if you have a GPU with less VRAM, like 8 gigabytes, 12 gigabytes, or 16 gigabytes of VRAM. Now, you can try different quantization sizes to see which runs best on your hardware and test the output of that LLM in different weights. One thing to note is that you can also use your CPU to run the LLM as well, instead of using the GPU. And while it works, it's also incredibly slow. So it's a good way to test out LLMs if you just want to get into it on whatever hardware you have on hand if you don't have any powerful GPUs. So now that we talked about what some of the different things mean when it comes to large language models, let's dive right into LLM Studio. So this is a free program that you can get right on their website, which can work with Windows, Linux, and OS X. It's a small download and it's easy to install. Just follow the installation instructions. Once it's installed, open LLM Studio and you'll be greeted with the homepage that allows you to browse different models. So this pulls models from Hugging Face, or you can import your own models as well if you have any available. So in this search bar on LLM Studio, it's pulling from Hugging Face, and that's an open source community for machine learning and natural language processing models. You can check out their website and browse models for yourself, and you can browse those models through LLM Studio as well. You can find modified models that have changes to increase token size, quantize differently, or they're fine-tuned and there's other modifications. We can get into some of that later. For the sake of this video, I'll use Meta's Llama 3 LLM, and there's an 8B and 70B model available in different quantization. So looking at the 8B model, you can see on the right side there's a README area with some info on the model, and then underneath that, there's different files that you can download. These are the models and the different quantization of that model. There's a Q3, Q4, Q5, all the way up to a Q8. Now, what I like about LLM Studio is that it gives an approximation of whether a model can work on your current hardware or not. You can see for all the different model quantizations, they have a full GPU offload possible, meaning I can use my 3090 Ti to run these models, and running it on the GPU is the fastest way for them to run. By comparison, looking at the 70B model, only one of the quantizations can be run fully on the GPU. And while one can run partially and the other one can't run at all because it's too big. At this point, feel free to browse different models and see which ones can run on your machine. Hit download and the models will be downloaded and they'll be accessible. I already have these two models downloaded, so we can go right into the chat window. On the top left, make a new chat window. This is where we can chat with the LLM. At the very top, you want to select what model to load. Click there and select your desired model. So we'll start with the Llama 3 model that I already have downloaded. Once the model is loaded, there's some settings on the side to look into. So on the top right, there's a preset that LLM Studio sets up for you depending on the model type that you're using. You can just use this preset and you can start chatting away with the model. But there's a few things that you may want to look at to get better results. First is the system prompt. So before we dive into system prompts and other settings, I do want to explain a few things. Now, large language models are exactly that. They're language, and it's a generative form of AI that generates language. So when you're giving it a prompt, you're giving that language model context. Now, there's a couple of different things that we're going to talk about. Some of that is going to be tokens and then context windows. So a token is a unit of data that AI algorithms use for processing. English words are converted to numerical values, and this is a token, and that can be processed by the AI. A good way of thinking about it is that one token is roughly the equivalent to 3/4 of an average word. So you can think of tokens as the amount of words that you have to work with. That's kind of the easiest way to think about them. Converting the text to numerical values is called tokenization, and this is a core part of how large language models work. So a context window is a specified range of tokens that are surrounding a target token, or basically your first input that you put. The size of a context window is the number of tokens that you have available in the AI's memory. That's really the easiest way to think about it. Any prompts and any responses in that window will have context within that window that the AI uses to generate its response, but this eats up a bunch of tokens. So this means that if you start a prompt asking about what animals Old MacDonald had on his farm, the AI has the context that it needs. So it'll start thinking about farms and animals, and it'll use that to generate the response. So within that context window, you can keep asking questions about Old MacDonald's farm, and you'll keep getting answers about Old MacDonald's farm. Your prompts and the responses from the AI, they're all tokens that are in that AI's memory, and they're in that context window. Once you hit the token limit or the memory limit of the context window, the AI will start forgetting the beginning of the context window, and it won't think about Old MacDonald's farm anymore. Once that context is lost, the AI can start hallucinations, where it'll randomly generate text of what it thinks is contextually important. So basically, 1 minute you could be talking about Old MacDonald's farm, and the next minute it'll transition to talking about McDonald's chicken nuggets because it's losing context, and it might change subjects entirely. The easiest way to think of it is that AI has a very limited memory where it's useful, and if you go outside of those bounds, it starts becoming much less useful. The size of the context window can be determined by the model that you're using, and different models have different token sizes for context windows. If you're using AI locally, then the context window can be limited by the hardware that you're using. So for instance, the hardware that we're using paired with the model that we're using gives us a token limit of 8,192 tokens, which is enough of a context window for us to get some pretty good results, but it's not as long of a context window as you could get in some cloud-based AI systems where they have 1 million tokens available. That's a really big context window. Now, there's modified local AI models that have context windows up to 32,000 tokens and beyond, but for the purpose of this video, I'm going to stay within that 8,192 token limit that's on Llama 3. Just to keep this whole thing streamlined. So now that we know a little bit about tokens and context windows, we can get into the system prompt. So you can chat with the AI right away, and depending on what you put in your first entry in the chat, that's what's giving the AI context for the conversation. The system prompt does the same thing, but instead of typing out a prompt at the beginning of the chat every time, you can use a prompt that you engineered to give specific desired results, while in the chat window itself, you can just start asking questions. We can do an entire video series on prompt engineering, but for the purpose of this video, I'm going to use a prompt library to demonstrate how LM Studio works. So scrolling down from the system prompt window, there's the context length. You can go to the max that the model allows you to use, and the model that we're using here is 8,192 max tokens. So I already have that set there. The temperature is the randomness of the model. Now, this is where creativity comes into play. By increasing the temperature, it adds a randomizer, so the answers that the AI gives will be more random and creative. But by lowering the temperature, it'll give less random and creative answers, and it will only give straightforward information. So an increased temperature is great for trying to come up with new ideas, while a decreased temperature is better for getting factual information. There's more settings available that you can play with, but the other major setting is the GPU offload. If you have enough GPU VRAM, then you can max out the GPU offload to get the fastest results. Now that we have everything set up, let's try out some different system prompts and see the results. So I'm using a prompt library from Anthropic, and I think this is a really good first step for people to play around with local AI and get a feel for what it's capable of. Okay, so first things first, I have LM Studio set up here. So I have my 70B model loaded, I have my token limit set, I have the GPU offload set to max, and here's the system prompt. So with the system prompt, I'm going to use the prompt library from Anthropic, and what I really like about this prompt library is they have a bunch of really cool and very different types of prompts. So the first one I'm going to try is this website wizard. I played with this one a little bit, and this one's really cool. You can see that they break it down. There's the system level prompt, and then there's the user prompt. So system prompt, we're going to put in this window on the right. User prompt is where we're going to put down here in the middle, user. And we're just going to dive right in. I'm just going to copy this right now, paste that into the system prompt window. Probably going to have to reload the model. That's fine. Usually anytime that you make a change with any of the settings, you have to reload the model. And depending on how big your model is or how fast your hardware is, it might take a minute. Now I'm going to go back. So we have that, and I'm going to copy the user prompt. But first, let's talk about what we're going to do with this website wizard prompt. So the system prompt is giving context to the AI, and it's telling it that your task is to create a one-page website based on the given specifications, delivered as an HTML file with embedded JavaScript and CSS. The website should incorporate a variety of engaging and interactive design features, yada, yada, yada. But you can see that the system level prompt is very specific, and the context that it's giving is you're basically telling the AI what it is. You are basically a web designer. That's what the system level prompt is doing. You're a web designer. Here are the specifications. Here are the languages that you're using, these coding languages. Once you have this kind of context in, it makes it easier to get the results that you want, instead of saying, you know, if you go in the user prompt and you just type in, make a website for me, well, it has nothing to work off of. You have to get very, very specific with what you put in your prompt. You have to be very specific with your communication to the AI. So the funny thing about AI and prompting is that it forces you to become a better communicator. You have to over-communicate to get your idea across to the AI so it perfectly understands what you're trying to do. You can always give it more context. You can always give it more information. So keep that in mind. Obviously, that's going to eat up your token limit in your context window, but that's okay. So I'm going to copy the user prompt here. System prompt is already in LM Studio. I'm just going to paste this here, hit enter. And one thing that I want to highlight is that on the right side, you can see under the system prompt that what we put in the system prompt window is going to take 99 tokens. And then what we put here in the user prompt window is going to take 322 tokens. So remember, we have that 8,192 token limit. This is already eating up a portion of that. So this is what you have to keep in mind when it comes to your context window. And there are context overflow policies in LM Studio. So if you hit that 8,192 token limit, you can just have it stop generating at that limit. So it might stop mid-sentence or mid-chat, and it just stops completely. You can also keep the system prompt, and you can keep the first user message in the system memory, and you can truncate the middle. So that means it'll always have that initial prompt and that initial user prompt. Everything else in the middle will just be deleted out of memory as it starts filling up. I do like using that because maybe I'll have a system prompt and a user prompt so it's in the right area that I want, but everything in the middle, I don't need it to recall on because I just need it to keep generating things. So that's actually the setting that I use the most. And then there's maintain a rolling window and truncate past messages. So this basically means that it'll just keep going forward and it's going to forget everything at the tail end. So once you hit that 8,192 token limit, everything at the beginning, completely forgotten. I like the truncate middle. I think that works for a majority of what I do. It depends on what you're doing. But now that we see what tokens we're eating up with our prompts, I have everything set here with the system prompt. Let's make a website and let's see how fast it is. Hit enter, and there it goes. So it's generating an HTML code, and it's pretty cool to watch. I mean, this is pretty fast in real time. And you can hear Al is whirring up a little bit. That's that VRAM going to work. And I can even open up my task manager and you can see, look at that, GPU utilization, 96%, 68 degrees. All that VRAM's being used up and it's still generating. That's why I have it on an open frame instead of a closed case, because I figured just let it dump heat into the room. All right, so there you have it. It generated a bunch of code. I'm gonna be honest, I haven't really used HTML much since MySpace days, but looks pretty usable to me. One thing I wanna highlight, at the bottom, you can see our speed. So we were 18.76 tokens per second. That's a pretty good speed. And our token count, we used 1,737 out of 8,192. So that's our context window. So we're still well within that window. We can ask it further things. We can ask it to revise things in this. But right now, let's just take this code for a test drive. So what I can do is I can just copy this, at least the HTML portion. And there's a JavaScript portion there as well, but I'll just do the HTML bit. I'm going to open up Notepad and just paste the code right in. I'm going to save it onto my desktop, call it test, and .html, hit save. There it is, test.html. And we'll open it up. Look at that. We have a website. It looks like it's straight out of 1996 and there's nothing on it. And it doesn't do anything because it's not live. But this is basically the core of a website. From here, you add all of the different pages, you fill out all of these pages. The system prompt is asking it, or the user prompt is asking it to make a one-page website for an online learning platform called EduQuest. And it has the following features and sections: a fixed navigation bar with links to different course categories, and it lists those categories. It has a hero section with a video background, and it has a couple of different taglines for those. Featured courses section, an interactive learning path section. So you can see here, it generated all of those things: success stories, contact form. So at the core of it, this is a website. Is it a great website? No, this takes a lot of work. But I think this kind of further proves what you can and can't do with AI. You can use it to generate HTML code to get what you want to get started for making a website. And then you can talk to it and ask it to make changes to some of these different things. Like I can ask it to generate this again, add another section for an AI training session with a sign up window. Let's see what it does. So here it goes, it's generating the code again. It's always real cool to watch. Oh, and what's funny is the pass-through on the 3090 Ti, it's pointed right at me, so I could feel all of the heat coming off of this GPU just hitting me. There's a lot of heat coming off of this guy. Yep, we're fully maxed out, 66 degrees, so it's cool off a little bit. Let's just copy the whole thing, let's see what happens. Save it. Close this window. Let's open up our test HTML. Look at that. I asked it to make a AI training session sign-up form. It put that. So instead of the contact us form, it changed it to an AI training session sign-up form. So if you want to add a section where people can submit their email, name, and a message box, there you go. All the Java stuff, I left it in, so it brings that up as a bunch of junk down there. But all the HTML stuff working pretty well. It's supposed to have an image and some other things to reference, but none of that exists just yet. So those are things that you have to change in the code. So it gets you started. It's kind of gets you there in terms of what you want to do if you want to make a website. But remember, there's a lot of work you still have to do yourself. Let's try another prompt from the prompt library. Let's see what we got. Oh, this should be fun. Storytelling sidekick. I'll make a new chat. I'll put this in the system prompt. You are an AI assistant with a passion for creative writing and storytelling. Your task is to collaborate with users to create engaging stories, offering imaginative plot twists and dynamic character development. Encourage the user to contribute their ideas. Okay. So let's start with, tell me a story about an associate working at microcenter named Carl. One day, Carl meets, meets the Mothman. Let's see what happens. What a fascinating tale. Look at it go. It was a typical Tuesday afternoon at Microcenter with rows of shelves stacked with electronics, gadgets, and software. Carl, a diligent associate in the computer section, had been working nonstop since morning, helping customers navigate the labyrinth of technology. This is going a little faster than I can read. The harbinger of the Mothman. Oh boy, this is going to get weird, isn't it? Carl's instincts kicked in, sensing something was amiss, yet he couldn't help but be drawn to the stranger's hypnotic gaze. The man's eyes seemed to hold a deep wisdom, as if they bore witness to secrets beyond mortal comprehension. "Who are you?" Carl asked, his voice steady despite the creeping unease. "I am the harbinger of the Mothman," the stranger replied, his voice dripping with an eerie conviction. "You, Carl, possess an innate understanding of the mysteries that lie between the threads of reality." So that's a pretty good demo, I think. 18.76 tokens per second again, only 1,300 tokens out of 8,000 tokens. So you can basically get this entire story about Carl's journey from Microcenter to meeting different cryptids. And you can do a lot with that. Let's try one more prompt. I'm thinking, generate questions for interviews. This one's kind of cool. System prompt, your task is to generate a series of thoughtful, open-ended questions for an interview based on the given context. Oh, very cool. Let's try this one. You are going to interview Steve Jobs on the Microcenter podcast. What are some questions and topics you can ask him that would create engaging content? Let's see what it says. What an opportunity. Yeah, I agree. Design and innovation. How do you approach designing products that are both innovative and intuitive, yet not compromising on functionality? Can you share a specific example of how you arrived at the design decisions behind pioneering products like the iPhone or iPad, entrepreneurship and leadership? Look at that. So in about 20 seconds, it generated an entire list of questions that we can ask Steve Jobs to get a lot of different kind of sound clips if we were ever to interview him on the Microcenter podcast. What key qualities do you look for in leaders when building a team, and how do you foster a culture of innovation within an organization? So these are a couple of different examples of what you can extract from a large language model locally. So what this demonstrates is that it all comes down to the prompt. Whether it's the system prompt or the user prompt, whatever you do to give it context, you always want to be as specific as possible. You always want to give as much detail as possible. And what I like about this prompt library is that it gives you a variety of different prompts so you can kind of see the thought process that goes behind how these prompts are made. So with the website generator, it gives a lot of specifics saying create a one-page website using HTML, using JavaScript, CSS. The website should incorporate a variety of engaging design features. So if you want it to do things, you have to explicitly tell it. If you want it to create engaging features, you have to say engaging features. If you want it to ask, questions to Steve Jobs that would create engaging content, you have to say that, and that's how you get questions asking it about the failed Macintosh from 1984 and the departure from Apple. That's a hard-hitting question to ask Steve Jobs. I'm sure he wouldn't appreciate that one. But the point being is that all of these prompts give the context to the AI, and the AI is able to take that and generate a response that is pretty good. So the takeaway here is practice your prompts, get as specific as possible. When you're creating that prompt, try to create a persona that you're applying to the artificial intelligence. Say that you are this, you are in news, and you want to ask someone some hard-hitting questions to get some very detailed answers. Now that we have a good feel for how to work with a local AI with LM Studio, let's take it one step further. The prompts that you're creating and the chats and interactions that you're having with the LLM are not permanent, and it does not train the model. Nothing about the model is changing with the information that you're providing it. The model is static. Now, you may hear things about training or fine-tuning, and that's a process of modifying the model that takes a lot more computational power than what I have available here. So if you have a bunch of documents and data and you want to use the LLM to help you summarize that data or search for things in that data, how do you make that work? Well, you could take that data, pour it into the prompt, and then you can use it that way. But there's another process that's called Retrieval Augmented Generation, or RAG. This is a way of optimizing the output from the LLM by having it reference an authoritative knowledge base outside of its training data sources before generating a response. This is a way of expanding the LLM's knowledge base without retraining. So keep in mind that training and RAG are two very different and distinct things. The point of RAG is to provide it the necessary data it needs without having to put it in the prompt yourself. So to do this, we're going to use another program called Anything LLM. This is a separate program that is going to work off of LM Studio, and I'll give a quick demo of how to use it for Retrieval Augmented Generation. So first, go to their website and install the program, and the installation is very quick and easy. Once Anything LLM is installed, you can connect it to any LLM that you're using, either locally or in the cloud. It actually has a lot of functionality there. But since we're using LM Studio, you can scroll down and you can see that there's an LM Studio selection. So you can just click on that. So once you open that up, it asks for the LM Studio base URL. Click back to LM Studio and you want to go to Local Server Settings. Load your desired model and press Start Server. This is creating a local server on your network that any device on your local network can access, but it also opens it up to Anything LLM. Think of Anything LLM as an extra layer on top of LM Studio. The default server URL for LM Studio is already in Anything LLM, http localhost:1234/v1. This will bring up the model that's loaded in LM Studio. Just enter your token context window, which is 8192 for the model that we're using, and you're all set. Now that it's set up, Anything LLM creates a workspace for you. Just name that workspace and you're ready to go. Here's where things get fun. On the left side is your workspace, and you can see an upload button. Click on that button and it opens a window that allows you to upload documents. You can enter website links, YouTube links, Confluence links. I think you can see where this is going. This is how you add data to your LLM. Now remember, this is not training, this is RAG. Now I'll do a few quick examples, but we're going to do a longer video about Anything LLM and the things that you can do with it separately. So I have a YouTube link for one of our recent podcast videos. I'm going to copy that link and go to Data Connectors on the window in Anything LLM. This will collect the transcript of any YouTube video and make it a searchable file that you can use for Anything LLM to answer questions on. Now, it takes a moment for it to collect the transcript, but once it's done, you'll see the transcript in your document folder in Anything LLM. Simply load this document into the workspace and you can start asking the AI questions about the data that you're referring to. So I'll ask it to summarize the podcast, and you can see that it gives a very high-level overview of our first episode of our podcast. But this is pulling information directly from our transcript of that video. This is really cool stuff. Now let's try a website. I'll use the About page from the Microcenter website, simply copy the link, paste it into Anything LLM, and fetch the website info. It'll download all of that information from the web page and put it into a document. Add that document to the workspace, and you're all set. I'll ask it to tell me about the history of Microcenter, and it generates a response based on the website data that I provided it. This is just scratching the surface on what you can do with RAG locally, but you can use your local documents, such as any Word docs, PDFs, anything else like that, and you can find creative uses to incorporate them into your AI workflow. Once you get all of this set up, start playing around with what documents you feed into Anything LLM and see what you can do. Remember, this is all run locally, and none of the information that you put into the workspace leaves your machine. So this is a good way to test the waters if you have privileged information and you want to see what you can do with it with AI. We're going to expand on the capabilities of anything LLM and RAG in a future video. We currently have this running on our network, and we're able to create an admin and user accounts for anyone on our local network to access the local AI system that we made, and they can feed it any data that they want and talk to that AI. This is a cool way to use a local version of basically Copilot or other cloud-based apps locally, and you can share it internally on a network. Overall, this was a very high-level overview of getting started with Local AI, working with LM Studio and anything LLM to create local AI workflows using system prompts and RAG. There's so much more that you can do, so remember to subscribe for future content on AI programs and demos from Microcenter. And remember, if you don't have a Microcenter near you, to comment #IWantAMicrocenter near me.